Okay, we are live. Hi, everybody. Welcome to my Curious Maths Facebook page and my live stream. I've got to be honest, this is my first live stream and I am feeling a little bit nervous, to say the least, especially about the technology, but we'll keep our fingers crossed. So let me tell you a bit about me before we start. My name is Sarah Tilley. I'm a primary maths consultant and I'm based in North London in Enfield. And I've been in education for over 20 years. And I have worked in the past for Enfield Local Authority as a maths consultant, training teachers, working alongside them in the classroom, just doing lots of mathsy things. And I now do a very similar job, really. I just work for myself. So I'm a massive fan of Numicon. I see it working all the time. I've been using it for years. It's absolutely amazing. And I was following a thread in Family Lockdown Tips and Ideas. It's an amazing Facebook group. And I noticed that lots of parents were saying that they had some Numicon at home, but they didn't really know what to do with it. So I offered to help, and that's why I'm here. So today, this is what we're going to do. The focus of this session is to give you tips and ideas for how to use Numicon at home with your children. And the age range I'm going to concentrate on today is 4 to 7-year-olds, so really early startings of mathematics. I'm going to do a little bit of modelling with Numicon, and I'm going to show some PowerPoint slides. But the most important thing really is I'm hoping you're going to be interactive. So using the chat button, telling me what you think, asking me questions. If I can't answer them now, I will definitely come back later and answer them all. But one of the things we always do when we're working together as teachers is we always practice. So one of the reasons I'd like you to have a go at some of these activities, and you may need to pause it and come back to it later, because I'm going to go at a fairly quick pace this evening. But the reason we practice is so that we can ensure we get the most out of the activity we set the children. And we also find that when we practice the skill or practice the activity, we kind of discover where the misconceptions might be. So we prepare ourselves a little bit for where children might go wrong. So that's why I kind of want you to do some maths and get your Numicon out and have a little go whilst I'm doing it on here. So let's start at the very beginning and think about what is Numicon. So when people talk about Numicon, often it's the shapes that they're talking about. So these are some of the Numicon shapes. But actually, Numicon is actually more about an approach. So it's an approach to teaching, a general approach to teaching, but to mathematics, where the idea is to keep the children busy and active. So we give them hands-on things like the Numicon shapes, and they can be active mathematicians and start learning. And whilst they are doing that, they can then obviously start communicating with their colleagues, their buddies on their table, and start talking about the maths they're doing. And of course, the other side of that is they're then practicing their sentences so that when they rehearse and tell the adults what they've done, they've had a go already. So, you know, it's really quite important to do all that. So what we're going to do now is I am going to show you a couple of activities, but the big thing to think about is when I'm talking about these activities, it's about this approach. So what questions can you ask your child? How can you prompt them to give you longer, fuller sentences? What else might they know? And so that communicating with each other and talking to each other is a really important part of it, and that is the Numicon approach. Okay, so it's not just the shapes, we've got that sorted. So the first thing I'd like you to do is I'd like you to get a Numicon 1, 2, 3, 4, 5, 6, 7, 8, and 9 and 10 shape. And what I'd like you to do is I would like you to put them into a staircase. Okay, I'm not going to say any more than that. Just have a little go. I'm just going to get mine ready. Okay, so a 1 to 10 staircase, that's where we start. This is what I'm hoping you're doing now. So if you note the way that I'm organising the shapes. Okay, now if I had a bigger space, I would have probably done it in a long line. So here's an example of a Numicon number line. And these Numicon number lines you can buy from Oxford University Press and get them easily. And that shows you what a number line would look like if it was out in full. So what I want you to think about now is, what do you notice? Because when we introduce Numicon to children, we want to talk to them about what they can see. So it's coming back to that doing and talking idea. So we'd always say to the children, what do you notice? Now, I'm hoping that some of you might be writing down in chat or sending in chat what you notice, because these are really important parts, really early conversations we need to have. So I'll take you through some of the ideas behind this. Just a few things to say. You'll notice the 2 is not placed around this way. It's actually placed around this way. And the reason it goes that way is, as you can see, it forms more of a staircase. So you go along 4 and you go up 1. You go along another 4 and you go up 1, and that continues the sequence. Okay. So first thing to notice, of course, is they're all different colours. That is important. It becomes very useful because a lot of children find it easier to remember the shape and the colour. They associate them together, but they're all distinct. Every single number's got a different colour. There are some similarities with the colours. So if I was to push forward, say, the odd numbers, you can see that they're orange, yellow, red, pink, purple. They're all sort of warm colours, and the even numbers are all sort of cooler colours. So that is also intentional. Okay, you'll be noticing that it's in what we call a pairwise system. So it's organised in 2s and one more, 2s and 2s, 2s and 2s. This is particularly helpful when we're doing addition and we're doing counting, and we want to start moving children away from counting in 1s to counting in 2s. That's absolutely brilliant. There's also loads of relationships, and that's what we talk to the children about. So if you look at number 3, it's got a relationship with number 2, and it's got a relationship with number 4. We can see that 3 is 1 more than 2, and we can see that 3 is 1 fewer than 4. They are similar, but they are different. So we've also got doubles relationships we can see quite easily. So for example, we can see the relationship that double 2 would equal 4. So we've also got a scale and mass issue. That's MASS, mass as in mass weight. So the brilliant thing about Numicon is that it's weighted. So for example, this one, if I was to put it into a balance scale, and when I'm talking balance scales today, I'm actually talking about pan balances. And pan balances are those balances which have got 2 transparent boxes at each end. They don't have to be transparent, but it's quite handy when they are. And they balance with each other. So if I was to put 2 of those things we call 1 in one side of the pan balance, and one of those things we call 2 in the other side of the pan balance, they would actually balance nicely. So if you've got pan balances at home, you can do lots of Numicon practice and maths practice using pan balances, sort of checking answers and all of that type of thing. So those are the main things to know about the Numicon shapes themselves. They're differentiated by colour. They've got a relationship. We've got a pairwise system going on. The holes, of course, I didn't mention the holes. They're really important. One of the reasons a lot of children take to Numicon so well is because of the holes, because they're countable. So they like to put their fingers into the holes when they're counting and put things into the holes. But that makes them incredibly useful. Right, okay, so what I would like to do now is show you a couple of ideas. So when I was thinking about what I could do today, I thought to myself that it would be useful to mimic perhaps some of the ideas that we do in school. So I was thinking about early years. So in England, Britain, that's sort of nursery reception age. And I was thinking about what kind of things do we do in school that you could mimic at home, because this session today is all about how you can use Numicon at home. So I'm just going to take you through a few ideas that I've found along the way. So one of the first things that's great for Numicon is printing with paint, because it's plastic, it's washable, it's durable. And when we start at the very beginning with children and we're attaching the Numicon shape to the number, we're doing a lot of recognising and a lot of identifying. we're not doing addition and subtraction at this stage. We're just kind of getting children to recognise the numeral, the mark we make on paper, to a value, to a word, that type of thing. So you could do some printing with Numicon. You could simply just let them do whatever they like and get excited with that. Or you could say, I want you to use the number 5 Numicon. Can you make me a painted print picture with the number 5 Numicon? Or I only want you to use the number 3 and the number 4. What can you make with that? But anything really, anything to do with sort of printing, paint, getting messy. I thought you might like to do some cooking. So another simple idea we use in early years would be to get some dough, basic dough, and as you can see, I've imprinted the Numicon shape onto the dough, popped it in the oven, and then we can eat Numicon shapes and talk about them. I've also included plasticine, because I thought a lot of you might have some plasticine at home. So if you've got plasticine at home and we're working on recognising and identifying, then you could use the Numicon shapes, or your child could put the Numicon shapes in the plasticine, and then they could do the cut-out numerals that we've got in the picture, and they could do some matching. So can they match the Numicon shape to the numeral? Next idea is a sandpit. Now, this is a big one. You don't need to worry about having a massive sandpit at home. A tray will work, get some sand. And a lot, we like to hide Numicon as treasure. So children love to get down dirty, don't they? They love getting stuck in with the sand and trying to find out what's at the bottom. So in this example, there's just some shells and some stones and some things. So maybe some jewels, or if your child is really into dinosaurs, maybe some dinosaurs hidden in the sand. And they can pick out and find those things you've hidden. And as you can see in the picture, they can match them. So they can match them against the Numicon shapes, and you'll see that they've actually matched them against the Numicon pattern. Excuse me. So, some more for you. Okay, we're getting exciting now. So this is an example of a water tray. It's not very deep, and it doesn't have to be this big. This is, we love glitter in primary school and making a mess, basically. So what's happened here is mix some glitter with some fluid and maybe something a bit thicker than water by the looks of it, and chuck some Numicon shapes in. You can see there's some numerals, and the idea with this is children go fishing, so you could get little mini fishing rods actually, and find the Numicon shape that matches with the numeral and matches with the picture. So you can see they printed out the Numicon shapes and put the number underneath. So if you want to get outside and get some exercise, you've got some hoops, or you could just mark out something in your back garden maybe, and you've got some bean bags. You could put some Numicon shapes, just like those numerals in the picture, put them inside the hoop, and your child has to throw those Numicon bean bags into the hoop and get the right number to match the numeral and to match the Numicon shape. Oh, I love this one. This one I found online. So fine motor skills with young children. It was needs a lot of work. So you'll see lots of ideas if you have a search online around padlocks for children at a young age to help them improve their fine motor skills. And this is a really nice idea where somebody has taken the Numicon shapes and put a padlock on them and then made some number cards. And the idea is you've got to match the key to the Numicon shape. So all these things can be for addition and subtraction. These are all fun activities to kind of play with the Numicon shapes, but with some meaning. I mean, I've known children sit in the book corner with some Numicon shapes, and whilst they're being read a story, actually act out the story with the Numicon shapes. So they can be really creative. And this is a nice example, hiding Numicon shapes at home. So you could hide them anywhere you like. You could hide them in their bedroom. You could hide them in a pair of socks. This example is covered in foil, and this works really well with the kids. They love this one. So the job here is they've got to find the shape and identify which number they think it represents, which Numicon piece is it. And it doesn't matter, it doesn't have to be foil, but the beauty about foil is that the children like poking their fingers through the holes to see if they've got the right amount. So, think about hiding some shapes around the house, going on a Numicon shape hunt, seeing what you can find, seeing what you can match. You could start talking about numbers and which one's more, that type of thing. Oh, and spinners. I've included these because you can go to Oxford University Press and buy Numicon and all sorts of resources But you can also buy spinners, and they're quite popular in schools because the idea is that you have a Numicon shape and your child spins the wheel, and whichever Numicon shape it lands on, they have to find. That's a very basic level, but of course you could include addition for that. So you could have 2 spinners and they could spin 2 of them and find the total. So there's lots of different things you could do with that. A few more. So once you've had a good old play and you've done all those fun type of activities, you would now be wanting to move them forward a little bit by doing a bit more matching. So they've done a lot of finding and recognizing and identifying. And now we want them to take that a little bit further to do a bit more connection making. So these are the types of things we might do in school. We might show a Numicon 5. And then we might show some objects, or we probably have them in our hands. But if we were doing it like this, we would have some objects to represent that 5. And I chose ducks for 5 little ducks. And you know that nursery rhyme, you can sing along. So as you can see, I've organised it in the same way as my Numicon 5. It is helpful when you're asking children to collect items. So you might show them a Numicon shape saying, go and collect pencils for this. And they run away, and it's quite helpful if they actually organise it into the same Numicon shape as well. So we'd also introduce the word. So you could be thinking about bringing that into your practice. How often do you actually bring that word in? And also the numeral, the mark we make on paper. So now we are attaching meaning across 5. We're thinking more about how it might look different. And that's important because we don't want children to think that 5 is just a Numicon 5. So we might bring in a 5 pattern on a dice or 5 pencils, that type of thing. So that's the kind of journey to sort of playing and recognizing and identifying. And what we're going to do now is we are going to actually, if you could get your Numicon 1 to 10 ready, please. We're going to need that to do a little bit of practice. So get your Numicon 1 to 10, remembering which way round to put the 2. And I am going to share my camera. So one moment. Okay, should be coming now. Right, so we've got our Numicon staircase again. And we've done lots of identifying and recognising, and now we're just going to start doing a bit more ordering and a bit more comparing. So comparing the shapes to each other and taking that a little bit further. So one of the really easy activity, and again, it's nice if you've got a Numicon 1 to 10 full out, but I'll just demonstrate it with a 1 to 5, is taking a shape away. So you could get your child, you could put all the Numicon shapes in a feelie bag. They could pull the Numicon shapes out. They could organise them into the 1 to 10 staircase. It might be that you're doing it at the same time, and then you can play a game with it. So it might be you remove the 4. So you're going to tell your child you're going to move a shape, take a shape out, put them back, and your child has to identify which one is missing. Now, we don't want to just leave it there because that's quite basic. What we want to do is do the communicating part of this Numicon approach. So the doing is the taking away of the Numicon shape, but the communication is how do they know? So when your child, well, there's loads of reasons for this one. So it might be that your child knows straight away because they've associated the colour green with the Numicon 4 and it's not there. They can't see the green. So they say straight away it's a 4. It could be that your child recognises that there's not a staircase in the same way because something's happened here and it doesn't normally look like it. So they might start pointing here and then they might be able to work out it's 4 that's missing. Or it could simply be that they go 1, 2, 3, 5. Oh, number 4 is missing. So taking a shape away and asking them to explain and giving them a chance. So all the things I'm talking about, you do with them and they do it back to you and you just play it as a game. Another thing you can do is put a shape in the wrong place. A bit more easy to identify. But if you take it that step further and you say to them, which one do you think is in the wrong place and why? So you might, might be able to say that the 4 is in the wrong place, but we want to know how they know. So we're hoping they're going to say, well, 3 is less than 4, perhaps. They might come up with that. They might come up with the fact that it goes down the staircase, so it can't be in the right place. But the point with all this is we're getting them talking about maths. And then we could also go further and we could swap to shapes. So we're going to ask them to correct our mistakes and talk about how they've noticed. And that's just a really nice way of keeping that Numicon approach going and keeping your child talking about the maths. That's really important. Now, just thinking about the first step of calculation, we often start with sort of one more. Numicon lends itself beautifully to one more, because what you do is you take your Numicon piece and you can put it on here to show one more. So I just want you to have a little go at that if you've got your Numicon out. Where do you think you would put your Numicon 1 if you were going to add one more to those? And you can always type it in chat. I'm looking forward to seeing all these comments later. So that's it. If I wanted to know what 1 more than 2 is, I can go to my Numicon 2. And if I put my 1 more than 2 there, we can see that it matches, and 1 more than 2 must be 3. So that works really nicely. And the pattern continues. So obviously if you go into 1 more than 3, you're going to put it in the gap so that it looks like a 4. And I'm using just numbers to 5, but of course you can go numbers up, all the numbers up to 20 for this if you need to. Now, what about 2 more than a number? Let's just have a little think about how you would work with your child on 2 more than a number. It's not quite as straightforward. So I'm going to pick up my Numicon 2. Now, when I do it on a 2, it works nicely because 2 more than 2 is 4, and I can check that. But that's not such a good model. It doesn't look like what they're used to. Do it like that, it just doesn't look the same. So when you move on to 2 more than the number, put it underneath. So you can see 3. 2 more than 1 is 3. 2 more than 2 is 4. 2 more than 3 is 5. So you notice I'm saying the full sentences because I'm encouraging the children to talk in full sentences and describe what they see. Okay, so let's think a little bit more perhaps about some addition and some early addition. We'll do that in a minute, but one other thing you can do with your Numicon 1 to 10 is you can get to see how well they understand the terms greater than, more than, less than, that type of thing. So I could say to the children, I'm going to put another number there, and actually just to put a bit more on that, make it a bit more tricky. So I'm going to say to the child, can you find 5? So if I say, can you show me 5? They're going to say yes. So can you find 5? So they'll grab 5. How do you know that that's 5? So again, I'm not going to be satisfied with them just doing this. So I'm going to ask them, I'm hoping they're going to say to me, well, I know it's 5. They might say, because it's red. So then you know that they're starting to remember. I know it's 5 because when I count it, there are 5 holes. Or I know it's 5 because 5's an odd number, and this has got a sticky up bit with no partner, so this must be odd. So we're looking for all of those kind of conversations, getting them to talk about what they know and what they can see. So after I might have asked them to, can they find 5 for me, I might say, can you find a number smaller than 5 or fewer than 5? And get them to choose one. How do you know it's fewer than 5? And they might take the 5 and the 4, and they might do a bit of comparing. And they might be able to say to you, oh, well, look, it's 1 less than 4. So we want to get them talking. We want to get them to explain how they know. They might say, it might be to do with colour again, because quite often children get really concentrating on that colour. The next step, you could take 5 for calculation and think about making 5 in lots of different ways. So I'm starting with a smaller number, but you can do this for other numbers. So I'm thinking about making 5 with 1s, and you could write the calculation down for them. So thinking about sort of nursery and reception, it's not an expectation that they can write the mathematical sentences yet, but certainly in year 1 and 2 it is. So you could be writing the mathematical sentences of what you can see, and you can see that 1 plus 1 plus 1 plus 1 plus 1 plus 1, have we done that right, is 5. And then you could say to them, any other ways? So what we're doing here is we're providing concrete apparatus to help them find all the possibilities, because maths isn't just about one right answer. Maths often has a range of answers. And this is an example in very early maths how this is true. So, you know, we know there are plenty of other ways to do it. We can, of course, do a 3 and a 2. And incidentally, it's quite, the first couple of times your child's using Numicon, they might find it quite difficult to match the shape on the top. So be patient and just let them play around with it. It takes a bit of time. I've spent a lot of time with children watching them trying to fit a Numicon shape over another. So that can be a little bit tricky. So think about doing smallish numbers, but actually finding all the answers. And that's what we do in school. So we're trying to go a little bit deeper rather than making the maths hard really quickly. So we're trying to expand their understanding. So once we've done things like finding 5s in different ways, we could think about adding 5 to a number. So we could take our Numicon 5, and it could be that we're doing, say, we're going to do 4 plus 5. So children might grab the 4 and take the 5. Actually, I'm going to change that to 3 plus 5 because I want to do something slightly different. And they're going to add these together. So they're going to count in the holes probably, and they're going to count on and find the total. Some children quite like to do that and kind of make the shape. And then what they do is they test, because we know that 5 plus 3 is 8, but they test to see the Numicon shape that fits above it. And then they know they've got the right answer. So 5 plus 3 equals 8. So I'd be saying to them, what does this show us? 5 plus 3 equals 8. So if we were adding to a number, now we can do that with bigger numbers, of course. If we had something like 15 and 14, we could do it in exactly the same way. Move these up a little bit so you can see them. So it's no different. So I'm using small numbers because it's easy and I haven't got a lot of space, but actually the adding is really easy with larger numbers. And lots of schools use this number line. So again, you can get this from Oxford University Press. It's really big. And it's a tens frame number line. So as you can see, they look just like the tens. So it goes up to 100. So you can do addition of much bigger numbers as they become more confident. And the way that we use this is we can put the Numicon shapes. If we were doing, let's say 14 add 12, we could put it on there and we could use the marks on this number line to help us. And we talk about how we're at 20 there and how we need to count on. So if the numbers are getting bigger, have a think about getting one of these number lines because they're really quite good. And then also missing number questions. So I'm going to use the example 5 add something equals 9. So this is early algebra and we do this right from year 1. Children finding a missing number, having to work out what they have to add to another number to make another number. And this again is particularly useful with Numicon. So once you've done lots of calculating and you think your child's ready to try and do some missing numbers, Numicon is a really nice way of doing it. So if I wanted to know what number I was going to add to 5 to make 9, I could get my 9 piece and I could put and again, a lot of children will kind of play around with that. I am quite happy myself to put it there. It makes no difference to me which end I put it. Some children quite like to put it at the beginning. So I've got 5 and I'm trying to make 9. How many more do I need? And you can see that it's very easy to count the 1, 2, 3, 4 holes that I've got left. So Numicon's really great for making it a little bit harder and thinking about missing numbers. What you can also do with missing numbers is you could put a 9 on one side of a pan balance, those pan balances I was talking about earlier, the ones with the transparent boxes. Put the 9 on one side, put the 5 on the other, and then if necessary you could take lots of 1s and see how many more 1s you need to put into the balance until you make 9. And the extra bit that you've added is what you have to add to 5 to make 9, which again is 4. So pan balance, or even just putting the shapes on top, it's a really nice way of doing it. Okay, now I'm going to show you something called the Numicon sandwich. It's a big favourite in schools around the country, and I wonder if you've heard about it. So I'm looking for a bit of interactivity with this one. So I'm hoping you're going to send a few comments in the chat box. What we're going to look at is Numicon bond. We're going to look at bonds to 10. So for 6 and 7-year-olds, we look at number bonds, which are two numbers which add together to make another number. And we look at number bonds to 10, and we look at number bonds to 20. And by the end of year 2, which is Key Stage 1 in Britain, so by the time they're 7, they're expected to be able to know and recall those number bonds really quickly and show really good understanding of inverse and things like that. That's subtraction, being the opposite of addition. So this is going to be our bread. And we're going to make a Numicon 10 sandwich. So what we're going to do is we're going to think about our number bonds to 10, and we're going to think about what two numbers equal 10. And for those numbers, we're going to give them some ingredients to go in our sandwich. And those ingredients are going to be very much linked with the colour of the ingredient of the Numicon shape. So let me give you an example. Now I'm going to be systematic. I'm going to start with the 9 and the 1. But children won't necessarily do that. And that's not a problem at all, because this is all about, over time, training them to be more systematic by talking to them and asking them lots of questions. So there's my bread. Here's my 9. Here's my 1. So I know that 9 plus 1 equals 10 because it's equal to the 10 piece of bread. You can see they have the same area. Now, ingredients. Now in schools, schools do it lots of different ways. So in some schools, they will agree ingredients as a year group. The teachers and the TAs will get together and decide and agree. And in other schools, the children will decide. So that kind of depends. But at home, I'm sure it will be the children deciding. So the job with this is that you are going to decide 2 flavours that when added together will make 10. And an example here would be aubergine and carrot. So that is a very popular flavour. So we know that aubergine plus carrot makes a Numicon sandwich. So 9 plus 1 equals 10. Aubergine plus carrot makes a Numicon sandwich. So we might say to them, oh, what do we have to add to aubergine to make our Numicon 10 sandwich? And it doesn't take them long to be shouting carrot. So that's the first one. So I'm going to give you a moment, because what I would really like you to do is think about the other sets of number bonds, so the 2 numbers that add up to make 10, and have a little think about the ingredients. So get your pieces and work out what they are. And I'd love you to put some of these ideas for ingredients in the group chat. The horrible ones are the most popular ones with children. So I know some schools who do like dragon's blood for a Numicon 5, giant's snot for a Numicon 8. Kids love it, but it's your choice. Right, so we've got aubergine and carrot. Let's go to 8 and 2. So to make our Numicon 10 sandwich, we are going to use a Numicon 8 and a Numicon 2. And we might call this lettuce, broccoli. I've heard it being called before. And I've heard this one be called blue cheese or blueberry, but we're having a broccoli and blueberry sandwich. How delicious is that? So next one. This one's a bit easy. Well, not easy, actually, they're all easy, but what I mean is this one, I get a bit more commonality across schools, because in most cases, this will be our cheese and ham sandwich. So when we're making our Numicon 10 sandwich and we've got some cheese in it, what other ingredient goes with it? So the children will be saying ham. And you can say, well, how much is a cheese? And they'll say 3. So 3 plus what makes 10? 3 plus 7 makes 10. Cheese plus ham makes 10. Okay, so then we got the 6 and the 4. Similar colours. Again, I get blue cheese for this one quite a lot. Cucumber for this lighter green one. Either of those would work. It doesn't have to be the colour that goes with the food. It really doesn't. It's just that a lot of children automatically go down that route. And for some of them, it makes a lot of sense. So we've got a blue cheese and cucumber sandwich. And then what's great is we can finish off. We get a chance to use the word double, which is always great. We could have a double tomato sandwich. or a double jam sandwich, or a tomato and jam sandwich, something like that. So it's a great one to do at home. Have a chat with your child and come up with some ingredients, and make some sandwiches and talk about what numbers you're putting in them and talk about the 2 that make the 10. Now, we do actually start thinking about a Numicon baguette as well. So when we go on to number bonds to 20, sometimes watch out for this, because sometimes when we do this one, what we find is children make 2 sets. So they end up using 4 numbers. So they'll do one number bond to 10, and they'll do another bond to 10, but actually they're not giving you 2 numbers which equal 20. So this one needs a bit of teacher modelling or parent modelling. And I advocate doing lots of these activities alongside your child, because if we go back to what the approach is all about, it's about talking, communicating, being busy, being active, and you can compare all the time. So what we're looking for with this is we're looking for the children to put a teen number in. So something like 13 as one of their number bonds. And then you can investigate what number needs to go with 13 to make 20. And some children will remember that 7 plus 3 is 10. Cheese plus ham makes 10. They might remember that anyway, so they might be very quick to say to you that 13 plus 7 equals 10. Now, little things like mixing things around, very important. Mixing structure around a little bit, but asking them lots of questions, getting them to talk about it, getting them to make a sandwich, talk about what flavours they're putting in, just get them talking and doing some maths. So I look forward to seeing what flavours you were thinking of. So what I want to do now is I just want to share a couple of ideas about more challenge. So we've talked about sort of recognising and identifying numbers. We've talked about matching and building in the numerals and the numbers. We've sort of done a little bit on more than, less than, and addition. But what I want to think about now is a little bit more about how you make the maths harder, because parents often want to know how to stretch and challenge their child in school. And one of the things that teachers say is make the maths deeper. So what we mean by that is don't make the numbers massive, because that doesn't make a good mathematician. Think about questions that make them talk about the maths, make them make comparisons, make them predict, make them wonder, and that will actually improve their understanding of mathematics. And that's a really important side, because as they go through primary school and secondary school and the maths gets harder, we want them to have a maths opinion and a maths voice. So I'm going to show you a slide that I actually shared with teachers just a few weeks ago. So I did a training course for Key Stage 1, teachers in Enfield, and we talked about challenge. So I'm going to get something called a feelie bag out. Now, a feelie bag really doesn't have to be anything fancy at all. It is simply a bag that you can put things in that is not transparent. I tend to use material because children can feel through it. So you could do loads of things with a feelie bag. So, you could have actually, when we were talking about 5 and identifying 5, you could have put some Numicon shapes inside the feelie bag and asked your child to find 5. Quick tip though with feelie bags, make sure you get your child to put both hands inside the feelie bag, because the idea about that is they're doing a bit of sorting if they've got both hands in the feelie bag. So if they were looking for number 5, then they could touch and feel to try and find number 5, and they could decide that a shape wasn't number 5, so they could put it to the side, and they could use that hand to kind of keep it separate whilst they have a little feel to try and find the actual 5. And of course, when they're doing that, you're going to say to them, have you found 5? And if they say no, you say, what shape do you think you've got? And they might say 3. How do you know it's a 3? And they might be saying, well, I'm counting the holes, or I can feel it hasn't got many holes, or I can feel it's an odd number, all of that type of stuff. So the feelie bag's a really good resource anyway, but I'm just going to show you a couple of questions that would get your child to think a little bit more deeply about some very basic concepts. So this is all about visualization. So one of the strengths of Numicon is that by using Numicon, your child gets a mental image of a value of a shape, and they can use that to help them solve calculations, ordering, comparing, all of that type of thing. So this is a question where you would say there are 2 Numicon shapes in the feelie bag, which total 10. One of them is 6. What is the other one? So getting them to think and deduce. So your child might want to pick up a Numicon 6. They might want to pick up a Numicon 10, put the 6 over the 10 and count to see how many more it must be before they give you your answer. Some of them might remember straight away, well, 6 plus 4 equals 10. Another example, so sticking to two shapes. This time, though, I'm going to ask them, give them an instruction by telling them that one of them is not something. So a lot of the time, children can very easily answer questions when we ask them what something is. And what we perhaps don't do enough is ask them what something isn't. Because if you know what something isn't, then you know what it is. If you know what I mean, that does sound a bit confused. But I think you know what I mean. So if one of them is not 8, what could they be? So I'm looking for the child to then say, well, if one of them's not 8, one of them can't be 2 either, because 8 plus 2 equals 10. And go through that elimination process and try and work out what the shapes could be. And you'll notice there's more than one answer here. Again, 2 different shapes in a feelie bag totaling 10. This time, note there I put the word different in, and that was quite important because I didn't want them to come up with 5 plus 5 every time. So I actually put in 2 different shapes equaling 10, and they're all even numbers. I'm looking for them to list all the even numbers and be able to tell me all the possibilities that they might be. Now, this is a very typical year 2, which is top infants, which is 7 years old, a very typical question. They have to be able to add 3 single digits. You don't need to make it total 10 in year 2. We do a lot harder than that. But if you put that 10 restriction on, again, you get them to reason and problem solve and wonder, because that's a really important part of the maths curriculum at primary school, is problem solving and reasoning. It's not just about calculation. And the best mathematicians, even the youngest best mathematicians, are the ones who can talk about the maths and make predictions and sort of make connections. So this time, that's really similar to the question I just did, and that's why I put it on there. This feelie bag has 2 shapes in it. The total is 9. What might the shapes be? So you could even say one of the shapes is 5. So that's really similar to the 5 question I showed a moment ago, which was 5 plus something equals 9. But I'm giving them a little bit of guidance. So they're having to make decisions. So this is what maths is all about, making decisions, making comparisons, changing their mind, all of that type of thing. Oh, that's the other part to that question. So the total of the shapes is 9. What shapes might they be? Samantha thinks that one must be odd. Is she right or wrong? Explain your answer. So that's a really important idea, because then we can start exploring patterns. And at the beginning, I talked about Numicon having structures, and that helps us be better mathematicians because we can spot them and talk about them. And it also highlights patterns. So the odd and even idea is really clear with Numicon. And we can start talking about patterns with what type of numbers do you need to have to equal an odd number? So you could do investigations over an odd plus an odd equals, an even plus an even equals, an odd plus an even equals, that sort of thing. And then we can kind of decide whether or not Samantha is right or wrong. We often use other characters in school to pose a maths idea and then encourage our children to agree or disagree with them, because we want them to have the confidence to say if they don't agree. So that's quite important. Right, okay, 25 robot. So I'm going to give you a little minute. What I want you to do, if you've got enough Numicon, is I would like you to make a Numicon shape that totals, no, not a Numicon shape, a Numicon robot that totals 25. I'm going to give you a moment to have a little go. Making a robot that is equal to 25 when you add those pieces up. So this is much harder than just adding. So we've got a restricted number. We're saying it's got to equal 25. So it'd be interesting. I always find it interesting watching children looking at how they're going to do it, because some children will just make the robot that they want to make, and then they'll count the holes and they'll see if they're anywhere near 25. Some will count them as they go along and try and add up each piece as they go. It's quite interesting, but it's much more difficult than just giving them a question like 8 plus 7. So we're giving them a restricted number. If you're having a go, you'll probably be finding it is a little bit more tricky than you think. So talk to your child about what I would do actually with this one is I would do one, and then your child should do one next to you. Your robots are not going to be the same, so it's a really good opportunity to talk about how they're similar, how they're different, but they've both got the same value. And you can do some comparisons. But if you're making one at the same time, if your child struggles with it, you can give them a little bit of guidance. And then you can take that a little bit further by asking them questions like, what is the total of the legs on your robot? What is the total of the arms on your robot? You could even compare the two. What's the total on both of our robot's arms? You could ask them what the difference is between the head and the body. And I don't necessarily mean colour there, because some children will go, well, the head is green and the body is red. That is a difference, but I'm talking more subtraction. So I'm looking at them to find a numerical difference between the body and the head. And again, we're looking for full sentence answers. So if you ask your child what the total of the legs are, you want them to say, the legs on my robot total blank, or my robot is equal to, or the legs on my robot is equal to. You could challenge them to make another robot, still 25, but with different pieces. So there's lots of things you can do. Here's a little example that was done earlier of a robot for 25. Right, okay, so what I'm going to come to a close shortly, but before we stop, I just want to talk a little bit about subtraction. So subtraction with Numicon isn't as straightforward as addition. And I just wanted to take you through why not, so that if you start doing some subtraction with your child using Numicon, you're just aware of a few things that might help you. One of the key things to think about when you're modelling, and what we talk about with teachers, and when teachers we chat at our planning stage, is making sure what we say matches what we're doing. Because it can be very confusing for a child, obviously, when you are saying something but doing something completely different. So that modelling part is really important. And I would recommend, perhaps for subtraction, if you're using Numicon, to use maybe pegs and marbles or plasticine, something like that. And I'll show you why. So what I'd like you to do is, I would like you to think about, let's do a simple question. Let's do 5 take away 3. So I'd like you to think about, how would you show your child 5 take away 3 using Numicon? Let's give you a moment to have a go at that. I'll move my Numicon out of the way. So we're looking at 5 subtract 3. Now we know our answer is 2. Now, one of the things around Numicon, and it's a massive bonus, but sometimes it doesn't lend itself beautifully to subtraction, but there's ways around it. And Numicon thought about this when they made and designed these pieces, but they're fixed pieces, which does prove a slight problem, because early experience of subtraction is about taking away. So a child will have some things, and then somebody might take some away from them, and we ask them how many they've got left. But it's really difficult to take away using a Numicon piece, obviously, because they are fixed. Now, you may see your child, and I've seen this lots of times in school, trying to break the Numicon piece, maybe. And if you said 5 take away 3, they'd be kind of trying to break the 3 off, but it's not going to work. So a few tips to make it work, because what some people instinctively do, and I made this mistake when I first started using Numicon, is if I was doing 5 take away 3, I'd do that. And you might have done that at home. But if we really think carefully about what we're doing, we want to make sure that the maths we're doing matches the model. So subtraction is taking away. Now, if you look at what I'm doing, you can see that for some children, that looks like I am adding. So I'm taking the 3 away. I'm not, am I? I'm adding a 3. So for some children, that's really confusing. So you could use something called Numicon pegs. Now you can buy these from Numicon, and you could get your child to find their Numicon 5 and fill their Numicon 5 with the pegs. So you're ready. I'm sure you're thinking, yes, that makes sense. I know where this is going. So if I've got 5, and I can check I've got 5, I know I've got 5 because I filled that, and I want to take 3 away. 1, 2, 3. I can see how many I have got left, and lots of children would like then to put that Numicon 2 over the top just to check that there are 2 left. They might even take it out of that and put it over there. So if you are going to use Numicon for subtraction, it does work really well as long as you do it in a way that makes sense. Think about using pegs. You could also use marbles. They'd fit in the gaps. Or you could download, I certainly know that you can get free printable downloads of the Numicon shapes, which you could then chop up. You could also do the plasticine idea from earlier on, and they could chop the pieces up. That would work really well. So I'm not going to do anything more on subtraction today because the ideas are consistent. So as long as I've done it for sort of 5 take away 3, it's the same idea for all of the others. But I just want to finish off by showing you a few last ideas. So I'm always looking online. I'm always kind of wondering what new ideas I can find. And so I had a look online and I put Numicon in a search, and I'm just going to get my PowerPoint ready. There we go. And here are some of the things I found. So these are some more fun ideas just to finish the session off, so you can take these away too. So I found lots of Numicon pictures. I've seen these in schools lots of times. So not dissimilar to the idea of the robot, but not concrete. So the robot was concrete because we had the pieces, but your child could be drawing pictures with the Numicon. So you'll notice here that they've tried to use similar colours. And we do try and do that in school if we can. So if we're using a Numicon 5, we'd colour it red. And the same for the painting earlier that I was talking about. But again, you could give them a restriction like the robot idea, or they could simply just make a picture. And then you could ask them questions about the picture. So what is the value of the body? Or, you know, what if they can see there's 2 trees there, how much are they worth altogether? So get them to pick it all off. They could say, if you took the arms away from the body, how much would you be taking away? So lots of fun ways to do it there. Another padlock idea, obviously quite fascinated by these. I think they're lovely. So there's a great big huge log there. I don't expect you to have that. But they've padlocked Numicon pieces onto something. And the idea is they have then got the matching numeral and the word, and you have to match the numeral to the shape. I quite like this one. So this is probably a school. So what we've got here is their Cheerios, I think, or certainly breakfast cereals, and fine motor skills again. So you could do it for an addition question, or you could just do it for recognising and identifying, using the little pincers to pick out the little Cheerios or breakfast cereals and put them inside the Numicon pieces. So I thought that was a bit fun thing to do on the breakfast table maybe in the morning. This is, I talked about spinners earlier, and I just found this example online, which is like a homemade version. So you can see they just printed out the Numicon shapes, and then you can't really see the pegs, but they're great. They've got numbers on them. They've got the numerals on them. So you can spin the wheel and put the peg and match it. Okay. Oh, one moment. Technical. Right, so next one. I love this one, Numicon City. So I've seen this done loads of times, and if your child is really into superheroes or anything like that, this will be particularly well received. A few different ways you can do it. So you can see here, this has been designed for them. They've drawn around some Numicon shapes, the adult, and the child needs to fill in the Numicon City with appropriate shapes. And you can see there's questions there like how tall are the buildings? So you could do lots of calculation around that. Or you can get your child to design their own city. So it could be completely random, and you could do a bit of counting, how many is this building? Or you could give them some guidance, and you could say, I want you to do a building with only even numbers in. I want you to do a building where you only use 5s and 3s. I want you to do a building where the total is 20. All those types of things. So again, keeping practical, getting busy. And finally, this links with the missing number questions I talked about earlier. So I talked about 5 plus something makes 9. I showed an example of putting the 5 over a 9 Numicon. I also talked about putting them in the balance and putting 5 on one side and 9 on the other, and then putting Numicon shapes in on the side of the 5 till they balance. This is another way they can do it too. So if they can count on their fingers, but this is just another padlock key activity where they have to work out what the missing number is to make 10 and add it on there. Okay, right. Okay, no technical glitches. We have got there. So this is the end of my first live stream. Woohoo! It's been an absolute pleasure. So I'd really love to hear your feedback. So please take the time to tell me what you thought of the session in the comments box. And I didn't get around to looking at any questions, but I will definitely go back and go through those. I hope you've really found this useful. I'd love it if you haven't already liked my Curious Maths page, if you would give it a like. And thanks very much for being here tonight. So next Monday, if you want another one, I am moving on to Key Stage 2. And that's sort of 7 to 11-year-olds. And I'm going to look at sort of multiplication and division, which also happens in Key Stage 1. It was just that I couldn't fit it all in. So it might be nice for you to come back next week if you want to and see some of the crossover of multiplication and division. But yeah, thanks so much. Take care of yourselves, look after yourselves, and hope to see you again soon. Bye-bye.